Theorem 4 of invertible matrix. In this module you will learn about Theorem 4 of an invertible matrix. Theorem. If A and B are two invertible matrices of the same order, then AB whole inverse equals the product of B inverse and A inverse. Let us now prove this statement. Let A and B be two invertible squared matrices of order M. Using the definition of inverse of matrix, we get product of AB within brackets and AB whole inverse equals I. Pre-multiplying both sides by A inverse, we get product of A inverse AB within brackets and AB whole inverse equals product of A inverse I. Using associative law, this results in product of A inverse A, B and AB whole inverse equals A inverse. Using the result A inverse A equals I, we get product of B and AB whole inverse equals A inverse. Pre-multiplying both sides by B inverse, we get product of B inverse B and AB whole inverse equals product of B inverse and A inverse. Using the result B inverse B equals I, we get AB whole inverse equals product of B inverse and A inverse. Let A be a matrix with elements 2, 3, 1 and -4. B be a matrix with elements 1, -2, -1 and 3. We also define inverse of these matrices as A inverse as a matrix with -1 by 11 as scalar multiple and -4, -3, -1 and 2 within brackets. B inverse is a matrix with elements 3, 2, 1 and 1. The product of B inverse and A inverse is given by product of scalar 1 by 11 and elements 14, 5, 5 and 1. This is statement 1. Product of AB is a matrix with elements -1, 5, 5 and -14. We also define inverse of AB is given by product of scalar 1 by 11 and elements 14, 5, 5 and 1. This is statement 2. From 1 and 2 we get AB whole inverse equals product of B inverse and A inverse. In this module you have learnt about Theorem 4 of an invertible matrix, which states that if A and B are two invertible matrices of the same order, then AB whole inverse equals the product of B inverse and A inverse.